At the foundation of discrete probability and probability in general, there are three important, very important concepts that you need to understand. Without understanding them, everything else we will say later will not make any sense, okay? These concepts are very simple, but it's very important that you understand them and you use this terminology that I'm going to introduce. The first one of them is the notion of experiment. Experiment is a procedure that gives rise to one of a set of outcomes, okay? So here's one example of an experiment. Toss a coin, okay? So a coin has two sides that we usually denote by H and T, heads and tails. And tossing a coin is an experiment. And the set of possible outcomes is either heads or tails. And when you toss a coin, you will see one of those, okay? Another one is roll a die, for example. So a die has 6 sides, and usually it's the numbers 1 through 6. You can roll a die. This is an experiment, and the outcome is the number you see on the top side of the die. Okay. Another experiment is generate a random graph on n nodes. Okay. So this is a procedure. You can write a computer program that takes as input n and for the number of nodes. And for example, you can generate random graphs from that where you start with n nodes. And then for every 2 nodes, with the probability 0.5, you add an edge. With probability 0.5, you don't add an edge, right? So what you end up with are these random graphs. Okay, and we have seen it in this course, by the way, when we talked about in one of the homework we had a computer program that generates graphs according to the Erdős-Rényi model of random graphs. And this is basically an experiment. This is a function that implements an experiment. Okay, so these are examples of experiments. And when we talk about the experiment, the next thing we talk about is the sample space. Okay, so the sample space is the set of all possible outcomes of an experiment. Okay, sample space is the set of all possible outcomes of an experiment. So let's look at these 3 experiments we put here. So tossing a coin. What are the possible outcomes of tossing a coin? The possible outcomes are either H or T, right? So this is the set of all possible outcomes from an experiment that is tossing a coin. For the second experiment, when you roll a die, you're going to see one of 6 possible values. 1, 2, 3, 4, 5, 6. Right? For the third experiment, the sample space is the set of all possible graphs on n nodes. The set of all possible graphs on n nodes. Okay, and I cannot write these explicitly in the case of the third experiment. Okay, but it's think about it, the set of all possible graphs on n nodes. So you can start with the simplest such graph. It's the graph on n nodes that has absolutely no edges. Then you can list the set of all graphs on n nodes that have exactly 1 edge. Okay, then you list all the graphs that have 2 edges, 3 edges, all the way to the set of graphs that have the maximum number of edges, which is the complete graph. Okay, the last concept we're going to talk about is the concept of an event. Okay, while the sample space is the set of all possible outcomes of an experiment, usually in probability theory, we don't talk about the probability of all these events. This is not what we are interested in, the probability of all these outcomes. We are usually interested in the probability of certain outcomes. Okay? So for example, when I toss a coin, I say, what is the probability that I get a head? When I roll a die, what is the probability that the number I see is smaller than or equal to 2? Okay? And when I generate random graphs on n nodes, I am interested in what is the probability that the graph will have exactly 3 edges in it. So when we talk about the probability of seeing a head, or the probability that the number when we roll a die is smaller than or equal to 2, and when we talk about the probability that the graph has exactly 3 edges, what we are talking about is an event Okay, so when I talk about what's the probability that when I roll a die, I will see a number smaller than or equal to 2, then I am talking about what is the probability of the two possible outcomes, 1 and 2. Okay, so an event E is really nothing but a subset of the sample space. Okay, so if we denote by S the sample space, E, an event, is a subset of that sample space. In particular, the empty set is an event because it's a subset. S itself is an event because it's a subset also of the sample space. Okay, but you can take any possible subset and you can count that as an event. So if we go back to these 3 experiments up there, is that if I look at, for the first experiment, what are the possible events? There are 4 possible events here: the empty set, the set that has just heads, the set that has tails, and the set that has heads or tails. For the second experiment, it's any subset of these 6 elements, right? So it can be the empty set or 1 and so on. I cannot list all of them. We have 6 elements there. There are going to be 6 choose 2 events, okay? Because every subset is an event. There are 6 elements there. There are 6 choose 2, okay? For the third, the event can be the empty set, for example, or the graph that has no edges, or a graph that has 1 edge, and so on. I cannot list them also. What is the number of possible events? It's the number of subsets of the set of all graphs with n nodes, okay? And you can use counting to reason about this, okay? So these 3 concepts are very, very important, and it's important that you understand what they are, and it's important that you know this terminology, okay, of an experiment, a sample space, an event, because this is where we are going to be defining probability on, okay?